the most durable adventure harness there is.
Heavy duty, extra durable, ultimate adventure dog harness.
You know, I could be really mean right now and ask Chad to do the math for that.
I'm not doing it.
After a little bit of calculus and differential equations, we come to the impulse momentum theorem, which basically says that if an object, our engine, loses momentum, it must be imparting force onto something, i.e. our harness. And since we already know that our delta t, or change in time, in the equation is tiny, we can assume that the force is going to be significant. The first thing that we need to do here is to find the free fall acceleration, since we are not falling at the rate of gravity. Again, we break out the old separable differential equations and derive the formula based on the change in position and the change in time, since these are both at least approximately attainable from the footage. With an approximate 1/3 meter fall in 1/3 of a second with a 181 kilogram engine, we can determine the final velocity of the free fall, which is equal to the initial velocity of our impulse momentum theorem. And just like that, we know that the harness would have needed to withstand 21,720 newtons worth of force to survive. And I know I went a little over some of your heads for a second there, so let me make it all worth it for you. Imagine now that you have a 100 kilogram or 220 pound Newfoundland dog that has the sprinting capability of a greyhound standing at your side. Our Newfoundhound sees a squirrel and sprints at maximum acceleration for 1 meter before you yank on the harness and bring the dog to a stop in just 1 second. To be equal to the force that we just put on the harness with our engine, you would need our monster dog and 32 of his identical buddies making the exact same pull at the exact same time. So basically Clifford.